Hello everyone, my name is Mohit Mittal and better this is a question of JEE Advanced. Let us discuss this question. So first let's take a quick read of this question. The question is that there are 2 moles of mercury gaseous is combusted in a fixed volume bomb calorimeter with excess of O2 at 298 Kelvin and 1 atmospheric pressure into HGO solid. So now in words we are given the reaction. The reaction that is given to us is that there is a mercury gaseous substance. It reacted with oxygen gaseous and it forms HGO solid. This is the reaction. Let me balance it first. So this is the balanced reaction. So it is said that we have carried out this reaction in a bomb calorimeter. During the reaction, the temperature increases from 298 to 312 Kelvin. So there is an increase in temperature. It means the reaction is exothermic in nature. Due to the heat released during the reaction, the temperature has increased from 298 to 312.8. Okay, now next is, if heat capacity of the bomb calorimeter and enthalpy of formation of mercury gaseous are 20 kilojoule per Kelvin and 61.32 kilojoule per mole respectively, the calculated standard molar enthalpy of formation of mercury oxide at 298 Kelvin is x kilojoule per mole. The value of x is, so we need to find out the enthalpy of formation of mercury oxide. बेटा हमें इसकी enthalpy of formation निकालनी है और हमें इसकी enthalpy of formation given है. तो कहने से बेटा अगर मुझे इसकी enthalpy of formation given है, इसकी तो जीरो होती है एलिमेंटल फॉर्म में आई है, इसकी निकालनी है, तो कहने से मुझे इस रिएक्शन का डेल्टा एच चाहिए. तो अब मुझे इस रिएक्शन का डेल्टा एच कहाँ से मिलेगा? देखो मुझे इस रिएक्शन का डेल्टा एच मिलेगा बाय द डेटा ऑफ बॉम्ब कैलोरीमीटर. Okay, so let's see first how much heat is released during this reaction. Okay, let's see. Let us do calculation part. So first we'll need to find out how much heat is released during this reaction. So let me write it as QV. Why do we write V over here? Because the in bomb calorimeter it is a fixed volume bomb calorimeter. So it means the volume is remaining constant. It means the heat is released in constant volume. So I can say QV would be equal to heat capacity 20 into change in temperature. So change in temperature is 312.8 minus 298, right? That is 14.8. So change in temperature is 14.8. So this will comes out to be 296 kilojoule. And since this is the heat released by this reaction system, so I can say it is a negative sign. We'll put a negative sign for this. And the heat released at constant volume is called delta U of this reaction. So we are given ultimately delta U. But what we need? We need delta H of this reaction. And there is a relation between delta H and delta U. And the relation is that delta H is equals to delta U plus delta NGRT. If I'm not wrong, I hope आपको ये याद होगा रिलेशन. ये थर्मोडायनेमिक्स में बड़ा बेसिक रिलेशन है ये. So delta U की बेटा वैल्यू पुट करते हैं. ये कितना आ गया? अच्छा, let me put a negative sign. Yes, right. So delta U is minus 296 plus. अच्छा, what is delta Ng? But delta Ng is the difference in the gaseous moles of product and reactant. So product, there are no gaseous moles. So 0 minus, right? And reactant we have 1 mole of oxygen and 2 moles of mercury. So total number of gaseous moles are 3 into RT is 8.314 into temperature is, the temperature in the question is given to us as 298 Kelvin by 1000 because by 1000 because the value of delta U is in kilojoule, so we'll convert it into kilojoule. And let us do the calculation part now. बेटा let's do the calculations. तो calculation बेटा आप अपनी कॉपी में करिए, मैं भी कर रहा हूँ. Yes, so this is minus 296 plus 7.42. So this will comes out to be 300 minus 303.4202. बेटा ये वैल्यू आ रही है हमारे पास 4202 किलोजूल. This is the delta H of this reaction. Okay. Now from the equation we can write the delta H of this reaction can be written as 2 times the delta H of formation of mercury oxide minus 2 times the delta H of formation of mercury, gaseous, right? So now in the data, delta H, the value is minus 300, 3.42 is equals to 2 times, beta this value we need to find out, and minus 2 times, beta delta H of formation of mercury is given in the question and the value is 61.32. Okay, so let me put the value 2 into 61.32. So which is equals to which implies that delta H of formation of HGO would be equals to, हाँ जी बेटे कितना आ जाएगा, देखो दिस इज इक्वल टू माइनस 303.42 divided by 2 plus 61.32. So this is equals to minus 151.71 plus 61.32. So this value will comes out to be, in terms of kilojoules, this value will, delta H of formation of HGO will comes out to be from here, yes, from here it will comes out to be, yes, this is 9 3.0, yes, minus 90.39 kilojoule per mole. So this is the right answer for this question. Let me put it in the box. Okay, so I hope the solution is clear to you, and if it is clear, please like the video and subscribe to our channel for more such kind of videos and share it with your friends. Thank you everyone.